Hi, this is number 4 on 7.3. A large candy company has a product that comes in several different colors. The company claims that the proportion of these candies are colored red is 0.32, or 32% of the candies are red. So suppose a random sample of n equals 400 candies is gathered. Let P hat be the proportion of candies from the sample that are red. So they want for all parts, and they're being very clear here in the very last parts as well. They want us to have 4 decimal places of precision. Okay. That's a great, I'm gonna love that this problem is being very clear with this. Anyways, it says find the mean standard deviation of the p hats. So the mean of the sampling distribution of the sample proportion, we have to really be focused, because in 7.3, there's both problems that talk about the mean, what is the likelihood of me getting a sample back with a mean value of something. That's a mean problem, and you have to use the sampling distribution of the sample mean and those formulas for the mean and standard deviation. And if this is a proportion problem, then you have different formulas for the mean and standard deviation. So here, the mu sub p hat is equal to the population proportion here, which is 0.32. So this first answer, 0.32. Then the second answer, the standard deviation of the p hats, that formula is square root of p1 minus p all over n. So the p is the population proportion stated above, so it's 0.32 times 1 minus 0.32 all over the square root of n, and n is 440, or 400, I'm sorry, it's 400. And so I'll just put that into my calculator, and they want us to be accurate to 4 decimal places. So let's go to the class calculator and let's go square root, so SQRT. And then I'm going to put in parentheses to let it know this all in the numerator, but like 0.32 times by 1, I put in parentheses 1 minus 0.32. And I'm in parentheses there, and I do one more parentheses to show it's all in the numerator, then divided by 400. And they give me this 0.0233. 0.0233 is our answer. .0233, was that it? Or did I just say that wrong? 0.0233. 0.0233. Okay, we're good. Okay. Then what is the probability of the p hat less than 0.297? So you have to remember this in this sampling distribution, the sample proportion, the x values, the values along the x-axis are decimal numbers. They are proportions. So the middle of this distribution, the mean is 0.32. And then so 0.297 is going to be to the left of that, somewhere over here. And then they say, what is the probability that it's less than? Where are the numbers less than 0.297? They are to the left. So this is the region they're trying to find the area of. So the cutoff is going to be negative infinity there. And then the other side is going to be stopping, the shading is stopping at 0.297. So that would be my lower bound here, LB, and my upper bound, UB. Okay, so if I was doing normal CDF for this equation, this problem, this first part, I would do normal CDF on my TI-84 calculator, my lower bound. Now I couldn't put negative infinity, so I put -1, and make sure to use the actual negative sign, not the subtraction sign. It's right under the 3. -1 EE, make sure not to use the E, but you're actually using, there's a EE button on your calculator, 2 E's, and that means the exponent E, I think, to help you. And then it's 0.297, or you probably don't have to put the 0 in there, but anyways, that's your upper bound. Then your mean is the 0.32, and then the standard deviation. They want you to put that to four decimal places. They're being accurate with that 0.0233. Right, and that's what you would put input. Let's see how we would do that on the class calc. So I would do distance, normal distribution, and then the mean was 0.23, I believe, right? And the standard deviation, I would normally put the whole formula in there, just so it's real accurate. But they have specifically asked us not to use the entire formula. They asked us to put the 0.0233. They wanted us to use it to 4 decimal places, so I'm going to honor that request in doing this. And then their lower bound was negative infinity, and the upper bound was 0.297. Let's look back at what that was. 0.297. Yeah, it's negative infinity to 0.297. So when I'm using class calc, this is my lower bound and that's my upper bound. And then, so my answer here is 0.9979, or actually I would round it to up to the 0 there, and this would be 8, so 0.9980. And let's just see if they like that answer. Oh, wait, less than. Hold on a second. I think I did something wrong. Like, let's just check. Oh, it's 0.32. That's why my mean is wrong. When I entered it in here, I had 0.323 and not 0.32. I'm just like, what's the typo? Now it's 0.162, 0.162, or 0.1618, 0.1618, 16. They just rounded it to 1.62. Okay, probably they would have hopefully 0.1618. Hopefully they would accept an answer like that, which they do. Okay, which they should. What is the probability of p hat is higher than 0.349? So the only thing that would be different with this one is they're still talking about the probability. So the only thing that's different is the picture that we would draw is a little different, right? This is the p, the mean is still 0.32, but then 0.349 would be to the right. And they want to see the probability if it's higher, where the higher numbers higher than 0.39, 0.349, it's over to the right. So our new lower bound would be 0.349, and our upper bound would be positive infinity. So when I go to calculate it in here, with my class calc, the mean and standard deviation didn't change, but like my lower bound is now going to be, what is that, the 0.3949. I believe that's what we had, 0.349, yeah. And then the upper bound is positive infinity. Let's see how easy it is for me to get positive infinity back in there. So I think just not having anything is probably, they're assuming. I'm gonna what I did is I see how this button, the division button, had a little sub infinity symbol. So I just pushed and held down the division symbol and it input the positive infinity for me. So otherwise you could have just blacked out and then they just started with from negative infinity and positive infinity, like they always input for you. But the answer here is 0.1066. So 0.10, let's see if they accept the 0.1066. And they should, even though they're 1 decimal away from us, but it's still good. All right. Have a great day, everyone, and I hope you found this helpful. Bye.